All right, so we're going to talk about a single box plot here. So in a single box plot, you can use the five-number summary to construct it. So if you remember from the last lesson, a five-number summary contains the minimum, Q1, the median, Q3, and the max. And in a single box plot, outliers are represented by an asterisk, which is just like a little star. And then the whiskers represent the highest and lowest values that are not outliers. And the box part represents the middle 50% of observations. So the lower end of the box represents the 25th percentile, which is represented by like a little bottom line there, and that's Q1. And there will be an illustration on the next slide, so it'll put it into more, be easier to understand. But the upper end of the box part represents the 75th percentile, and there's a top line there, and that's Q3. And then the line in the middle of the box represents the median. So we can put this all together here in an example. So just starting from the top to the bottom, you see the first star up there, that represents an outlier. And then as we go down, the first arrow is the largest value that's not an outlier. So at the top of that vertical line there, that would be the maximum. Or not the maximum, but but that's just the largest value that's not an outlier in this case. And then it goes down, and then the first horizontal line is Q3, which is the 75th percentile. And then the middle line in between the box is the median. And Q1 on the bottom there is the 25th percentile. And then as we go down, you see the smallest value that's not an outlier. And then below those are two asterisks, which are more outliers in the bottom. So you see the box, you can calculate the IQR since we're given Q3 and Q1. So if you just subtract Q3 from Q1, you'd be able to get the IQR there. Okay, so there's a way to identify outliers through a data set. It's called the IQR method. So if you take Q1 and you subtract 1.5 times the IQR, that will give you your lower fence, as we'll call it. And if you take Q3 and you add 1.5 times IQR, that will give you your upper fence. So any observation below the lower fence or above the upper fence is considered an outlier. So those numbers act as barriers kind of for the data set. So if there's any number lower than the lower fence, then that would be considered an outlier. And if there's any number above the upper fence, that is considered an outlier as well. So this is just a way to calculate, to identify outliers using Q1, Q3, and your IQR. So we're going to go over an example here. So a teacher wants to examine students' test scores. Their scores are 74, 78, 80, 84, 88, 90, 90, 90, and 94, and 98. So which set correctly represents the five-number summary from this data? So look over the set, and we're actually going to go over this in once you guys get your answer. So you can type your answer in the chat box once you get it, and we'll go over it in a bit. All right, great. So our answer here is B. Oops, sorry. Okay, so going over the five-number summary, so we start with our minimum. So the numbers here happen to be listed in order. So the minimum and maximum, we can find those by just looking at the first and last number since the numbers are in order. So the first and last number must be 74 and 98 since that's the minimum and the maximum. So that means B and C are our options here. And then looking for Q1, we see 80 is our Q1 here because that is the 25th percentile here. And then going into the median, we find that our middle two numbers are 88 and 90. So we just have to take the average of those two numbers and we get 89, and so on through the rest of the 5-number summary. Yep. All right, so now that we have the 5-number summary, we can use the IQR method to see if there's any outliers. All right, so our 5-number summary, we just got that. So we can calculate our IQR by taking our third quartile, which is 90, minus Q1, which is 80, and we can get an IQR of 10. So we can start calculating through the IQR method our lower fence and our upper fence. So we take our formula for the lower fence and we plug in Q1 and the IQR of 10, and we get 65 as our lower fence. And then we take Q3 and plug it into the upper fence as well as the IQR, and we get 105 as our upper fence. So now all we have to do is look at our data set from before, which I'll actually just pull it back up, and see if there are any numbers below 65 or greater than 105. So we look, and our lowest number is 74, which is greater than 65, and then our highest number is 98, which is less than 105. So no, we don't have any outliers present. But any scores below the lower fence of 65 and above the upper fence of 105 would be considered outliers. So if they got more data and they got a score of 110, that would be considered an outlier. Or if they got a score as a 55, that would be considered an outlier as well. So are there outliers present? No. Okay, so there's a chart to compare one quantitative variable with one categorical variable. So for example, if you compare the heights of males and females. So in order to compare one quantitative and one categorical variable, we can use side-by-side box plots, dot plots with groups, and histograms with groups. So first with side-by-side box plots, which is what we have here on the right, side-by-side box plots easily compare the median, IQR, and the range of two groups, because you can easily look at your IQR from the boxes in the box plot, and you can see the median, which is the center line in the box plot. So you can tell where, you can just see easily where the data matches up. So in this case, you can clearly see that the median for females is less than the median for males, since that center line in the box plot is lower than the center line in the box plot for males. Okay. So dot plots with groups and histograms with groups, as I mentioned before. So these two are more similar. They compare the shape, central tendency, and the variability of two groups. You can kind of see the patterns between these two but with the box plots, you couldn't really see. You couldn't see the shape. You can't really see shape with box plot or central tendency, but you can, which we'll discuss later. There's possibility for box plots to be skew. But first, starting off with histograms of height, you can just see really the difference between these two are the bars and the dots, but pretty much you can see that they have the same pattern overall. They're pretty symmetrical. Females, pretty symmetrical. It's not too skewed. The male is skewed more to the left, but you can just see the patterns in those two and how they line up next to each other. Okay, so distributions for two quantitative variables. We just talked about distribution for one quantitative and one categorical variable, but we'll be talking about scatter plots, correlation, and simple linear regression. We're not going to go into too much detail with correlation and simple linear regression, but we're just going to get familiar with it for now. Okay, so scatter plots are used to show the relationship between the explanatory and response variables. So the definition of a scatter plot is a graphical representation of two quantitative variables in which the explanatory variable is on the x-axis and the response variable is on the y-axis. So just some things to consider when you're examining a scatter plot. So you want to look at the direction of the scatter plot, if it's positive or negative. So you can identify a positive scatter plot by if the dots go from the bottom left corner to the top right corner, and a negative scatter plot would be dots going from top left corner to the bottom right corner in a negative direction. So if it's linear or nonlinear, if the dots seem to go in the same direction, the strength of the scatter plot, how strong the relationship is between the two variables that you're comparing, and then just looking for outliers there. So here's an example of a scatter plot. So we can look at those factors that we just discussed. So first is direction. So we conclude that there is a positive relationship between height and shoe size, because if you notice, as height increases, shoe size increases as well, and vice versa. Again, if height is to decrease, then shoe size would decrease. So next, going on to form. So the form really shows how strong a relationship between shoe size and height is. You can see that there is a pretty strong relationship because each dot seems to be following the same pattern there. And then there really aren't any outliers here that are sticking out. Obviously, all the dots are not going in the exact same direction, but there are no outliers here for the most part. Okay, so correlation is a measure of the direction and strength of a relationship between two variables. So just like mean and proportion, correlation has a sample and a population. So it has two different symbols for samples and population. So the sample symbol is R, lowercase r, and the population symbol is rho, which kind of looks like a P, but it doesn't have the extra tail at the top. But so it's just kind of like an O with a little line at the bottom of it. So there are 5 properties of R that you just want to keep in mind. So correlation ranges from -1 to +1. So if your R is greater than 0, that means that there is a positive association, which makes sense because that would be positive. And if R is less than 0, there is a negative association between the two variables. So the closer R is to 0, the weaker the relationship is. And the closer R is to -1 or to +1, the stronger the relationship is. So another thing to keep in mind is that correlation has no unit to it. It's the same for everything. So if there's really just no units. So just keep in mind that there's no units to correlation and that it just ranges from -1 to +1. And the correlation between x and y is equal to the correlation between y and x, so it doesn't matter where your variables are on the chart or what order you say them in, the correlation will still be the same. And here's just a chart showing the strength of your relationship in correlation. So this doesn't have to be specific to the decimal, very weak, weak, moderate, strong, very strong. It's just something to keep in mind as you go along. You don't have to memorize this chart by any means. It's just something to keep in mind on how they define the relationship, but this is just showing how the strength ranges from very weak to very strong. All right, and some things to look out for with correlation. So correlation does not equal causation. So I know that, for example, Professor Zimmerman sent an email saying that some of the tricks, not tricks, but some of the things that successful students have done in the past to improve their grade in the class. But just because you do those things doesn't necessarily mean that your grade will improve. But the students who do that tend to do better in the class, so correlation does not equal causation. So students typically have done better, that's the correlation, but it does not mean that that will result in you getting a good grade automatically. The next is R should only be used when there is a linear relationship between x and y. And then R is sensitive to outliers. So your correlation will change as you have outliers. So that will make the relationship more weak if there are outliers there. Okay, so simple linear regression is when you use a straight line to predict the response variable when you use one explanatory variable. So this is expressed using the formula y equals a plus bx. So if you've seen an algebra before, it's similar to y equals mx plus b. It's very similar. So y would be the predicted value of y for a given value of x. A is your y-intercept, and then b is your slope, and then x is just your x value here, your explanatory variable. So you would typically use this to predict your response variable or your value of y for a given value of x. So residuals. Residuals can result from the simple linear regression method as we just went over. And a residual is the difference between an observed y value and a predicted y value. So you can predict a y value using the simple linear regression equation, and then you can also get an observed value from taking data. So you can find a residual by just finding the difference between your observed y value and the one you predict using the simple linear regression method. Okay, so relations between multiple variables. So scatter plots within groups is different from a normal scatter plot that we went over with just two quantitative variables. But a scatter plot with groups is used to display the relationship between two quantitative variables and then one categorical variable. So if you see on the right there, we have a scatter plot with groups that shows weight versus height. And then those are the two quantitative variables that are measured here. And then it also adds in another categorical variable between males and females. So it's easy to distinguish between the males and the females because the females are in the blue dots and the males are in the red dots, so it's easy to tell. But you can just see how the data is all put together, so it's kind of hard to see like a pattern between the two. But here the quantitative variables are on the x and the y-axis, and then the categorical variables can be represented by color or different shape. Here they're both represented by color and a different shape, but sometimes it'll just be one or the other. Just something to keep in mind there. So bubble plots are some, you may see them. They're very fun. They can be used to display data concerning 3 quantitative variables at a time and a categorical grouping variable. So this chart, I think it shows days going to the gym. That's what is represented by the bubbles here. And then it shows how that is related to weight in pounds and height in inches. So you see that the bigger bubbles are the ones that are more common. So you can see that the bigger bubbles go below the line of best fit. So the height, the smaller height you have, the lower weight you'll have. Okay, so a time series plot displays time on the x-axis and then a quantitative response variable on the y-axis. So something just to keep in mind when going over time series plots is that the time is always on the x-axis, and then the other quantitative response variable, y variable, is on the y-axis. So here in this case, we have the year and then the estimated spending per year there. So just keep in mind, time is always on the x-axis here. Okay, so here's a review of box plots. So according to the box plot, which of the following is represented by a score of 525? Okay, great. So C is our answer here. So Q1 would be represented by the bottom line, which looks to be around 500, 505. So that can be our answer. B, minimum. Minimum would be below 500, so that's definitely not what we want. And then C, median is our answer because, again, it's that center line, and it should be around 525, not exactly, but great job. Okay, so which of the following values of R could be used to describe a very strong positive association? Okay, so our answer here is A. Keyword here, there's two keywords, strong and positive. So positive is the difference between A and C here. If they were just looking for just a strong association, A and C would both be correct answers. But since we're looking for a strong positive association, our answer would be A. And 0 is just not a strong. There's no relationship at all there, so that cannot be our answer. But since we're looking for a positive association, A is our answer. So which of the following statements cannot be concluded regarding the scatter plot? All right, so our answer here is B. So we're going to go through each answer. So A, there is a positive linear relationship between height and weight. So this is true because you can see the data is going, or the dots are going from the bottom left corner to the top right. So that's a positive relationship. B, this is a scatter plot with groups, so that is not true all the way to the end. C, there is a moderately strong relationship present. Yes, that is true because the data seems to be going in the right direction, but not all the data is in a straight path, so that's why it's not a very strong relationship. So moderately strong is correct. And none of the above is not true because B is not true. So this is a scatter plot with groups, so we see that there's only one group here. There's not two groups, which is why it cannot be a scatter plot with groups, so it's just a scatter plot. If it were a scatter plot with groups, you would see two different types of data being represented on the graph. So right here, we only see dots, blue circle dots represented, but if we saw another type of dot, that would be a scatter plot with groups.